All right, here's how you can use Desmos to form a regression line. So the first thing you need to do is click on that plus, hit table, I've already done this, and enter your values for x1 and y1. Once you've done that, then depending on what type of function it is, you type in the following. So you have to address the x1 and y1 that are on the top of that table though, there. So you type y1, notice it puts a little subscript there. It also says that there's 7 elements in the list. So if you look above, there's 7 things that it's looking for. And then you use a tilde instead of an equal sign to say, let's approximate the relationship between x and y. That's sort of how I think of it. And then you just type out the equation. So it's mx, and again, we're referencing the x from above there, so you have to use x1. So mx plus b. And there we go. We've got a line that hopefully is like an average line that goes through all those points. The one thing that bothers me right now is I can't really see any of my points. Like I can try and bring that down, but we're talking in the hundreds there. So an easy way to change what you're viewing is to click on that little wrench tool there, and then change your x and your y values. So my smallest x is like 1.3. Is that right? How come I have two 1.3s? I might have made a mistake there, but you'd want to go back and check your numbers. Anyway, my smallest is 1.3 and my largest is 5. So my x's, maybe I'll start at 0 and go to 6. That gives me a little bit of a range. I still can't see them, and so let's change our y values. The smallest y value looks to be about 330 something. So why don't we say, let's start at 300, and let's go up to, I don't know, the highest one's 900 something, so let's go up to 1,000. And there, you'll see now that I see those dots that are on my screen. I'm just gonna check to see if that one number is right. Let me just do that quick. So there's two 1.3s. Okay, so you look at the red line and it looks like an average of all those dots. And the dots seem to be in a linear kind of way. There's a linear shape to it looks like it could be a straight line. So then I take, and at the bottom there, my slope and my y-intercept. I'll talk about the r value too in a second, but I'm going to take the slope and the y-intercept and I'll put them in an equation. Okay, hopefully this video part will work. Okay, so once you find this regression line, you get all this data that's down here. And so let me talk about the r value first. So the r value is basically how close are you at averaging all of those points. So an r value of 1, exactly 1, would be perfect. So that would mean all the dots would have been exactly on that line. R's is 0.98, or you could call that 98%. You could say you could think of it that way, as being 98% accurate that line reflects those dots. And you can use that R value to tell you whether picking a linear function, like we did, is the way to go, or whether maybe another function would be appropriate. Now the stuff at the bottom there, that's what I wanted to show. So since this is a line, that's the equation of a line. And Desmos, when we did that regression thing right there, it tells us what the slope should be. So I can type that in. So 170.514x plus, and it also tells me the y-intercept, 130.555. So that is the equation of that red line. So we could ask some questions on that. We could say, well, if x is, say, 10, what's y going to be equal to? And to do that, then I would just take and put a 10 in right there. So 170.54 times 10 plus 130.555. Figure that out. That'd be 1705.4 plus 130.555 it'd be 1835.955. So the value of y when x is 10 would be that. Okay, so that's linear functions. Let's look at quadratic functions. Okay, here's another example with a quadratic function. But let's confirm that it's quadratic. I still have my scale from the last time I graphed here. I'm just going to hit the tool thing. Okay, whoops. And I want to get x's. So x is my smallest, x is 10. Largest is around 64. Why don't we go 0 to 70 maybe, just to give us a little bit of room. Oh, there I can see some of the dots there. And then my y-axis, my smallest y, 115. So let's maybe go 100. And then my biggest one, 285. So maybe I'll go to 300. There we go. Okay, so there now I can see the data, and it does look like a parabola. And that's one thing you want to, when you look at your data, check to see if it's a linear function or a quadratic function. Could be a trigonometric function or logarithmic. It could be lots of them. But let's see how close we can get a quadratic function to display this data. So again, we'll do the same thing. So I got a y1 and then a tilde. And then now here I have to type a general equation for a quadratic function. And we've looked at two of them. I'll do both of them. So the first is ax1 squared plus bx1 plus c. So when I do that, if you notice down below there, it gives me a value for a, b, and c. It gives me a negative value for a, and that makes sense because it's upside down, the parabola, right? You look at the parabola, and it looks like it matches pretty close to those dots that are there. It doesn't hit all of the dots, doesn't hit many of them actually, but it does look like a fairly good average line. So I'd be fairly confident with that. Now, like we talked in class, the ax squared plus bx plus c, that formula, it does give us the direction of opening, so it opens down like this. It also gives me that c value, which is the y-intercept, which I look down below, it's 22.7625. But I can also use the other vertex formula that'll tell me what the tip of that vertex is. So, and that one is y1 and then tilde a, and then inside here I've got x1 minus h squared, and then plus k. There we go. So now that's telling me the, again, the a value, the a value is identical, eh? But then the h and the k value, they're telling me where the vertex is, or where the highest point of that parabola is. So it's up there. So the highest point happens in an x value of 41.773 and a y value of 281.58. So you could ask yourself, okay, what's the highest point that it's going to be? It's going to be 281, and that'll happen at an x value of 41. If this was like a ball that was thrown, it would go 281 meters up in the air, and it would take 41 seconds to get to that maximum point before it started falling again. Something like that. Other questions that we could ask is we could say, well, what would the height be after, say, 20 seconds? So a quick way to do that, I could plug a 20 in to the quadratic formula, not quadratic formula, but into the quadratic equation wherever there's an x. Or on the graph, I could just type x equals 20. And right there is the point at an x value of 20, this rock or ball or whatever I threw would be 198 meters up. Another question that you could ask is, at what time would this rock be, say, 150 meters up? So if you type y equals 150, it puts a line at 150, and again, I can just tap on those points. So after 14 seconds, as if we could throw something that'll stay up for 14 seconds. Anyway, at 14 seconds, the projectile or whatever it is will be 150 feet high. And it goes up to the top, and then as it's falling, it also hits 150 again, which would happen at 69 seconds. All right, so hopefully that gives you an idea of how you can use Desmos to find a regression line for a set of data. All right, similar to what we did with the linear function, when we do the regression and we come up with this data, this R value, wherever the R value was, gives us an idea of how close we are. And I think that one's fairly close. But it also gives me values to plug in where the A, B, and C are. So if I wanted to, I could write this equation as y is equal to negative 0. Let's just round to 2 decimal places, x squared, and then the b value is 14.6 or 14.57. So plus 14.57x, and then the last value, the c value, is negative 22.76 minus 22.76. So that is the equation of that red line. And it's written in sort of the standard form of a quadratic equation, where this would be my y-intercept. So down there somewhere, wherever that is, yeah, down there somewhere at negative 22, that's where it would cross the y-axis. Now I can also write it this way. I did both of them. And so if I was interested more in what the vertex was, I can use this vertex formula. So again, it'll be negative 0.17, and then x minus, the h value is 41.77 squared, plus the k value is 281.58. So that would be the equation, again, of this line, just written in a different format. The nice thing with the vertex format is it tells me what the vertex is. So it's 41.27 and 281.58, like you saw in the other video. That's that point up there. All right, hopefully that helps you with using Desmos to find either linear regression lines or quadratic.